Tactics and Practice Podcast.
Dobar dan, everyone, and welcome to the Tactics and Practice Podcast, the audio extension of the Aksioma Institute for Contemporary Art's discursive program of the same name, focusing on investigative art, society, and new technologies. Each year, Tactics and Practice focuses on a specific theme. The 14th edition, held in Ljubljana in the spring of 2023, was dedicated to scale. I'm Neja Berger, and I followed the entire program, interviewing some of its protagonists for this channel's first mini-series. I'm finally ready to share it with you, one episode at a time, on a weekly basis. And we kick it off with writer and independent researcher working at the intersection of technology, philosophy, and media, Laura Tripaldi. Hi.
Hi, Neja. Thank you.
Laura was kind enough to join me at my flat, and she is now being harassed by my pets. So today we'll talk about some of the ideas brought forward in your book, Parallel Minds, Discovering the Intelligence of Materials. I'm someone who comes from the arts and humanities, where we famously like to complain that, the natural sciences people are not considering the social and philosophical implications of the research enough, that they're not interdisciplinary enough. But maybe it's worth pointing out that we don't particularly go in depth in terms of understanding their disciplines either, probably with some exceptions, of course. But today I'm really happy to meet someone who I would say is not only truly interdisciplinary, but transcends disciplines, questioning their boundaries and producing something which can be a concept or just a shift in paradigm from these relationships between them. So I didn't want to define you too much in terms of your academic credentials and everything in the beginning. So maybe if you want to introduce yourself first.
Of course. So thank you, Neja, for your kind introduction. Yeah, as you said, I come from a scientific background. I studied chemistry in university, and then I went on to do a PhD in materials science and nanotechnology. And this was really very applied research. So I started working in essentially developing innovative materials for the reinforcement of rubber for tires. So this was like a really industrial and applied field of research, right? Then I started to get interested in some more speculative aspects of science, let's say. And maybe this is kind of unusual because I feel like, I had the feeling, especially when I first started doing these kinds of interdisciplinary experiments, that most people that were bridging science and philosophy often came from fields such as theoretical physics or really fundamental biology, evolutionary biology. But there was not really a lot of intersection between like these more applied fields of science and philosophy. So yeah, I would say that this background in applied science really shaped my approach in the interdisciplinary research that I've been doing, because most of all, I've been interested in trying to answer the question of what is our relationship with technology as humans, and what kinds of paradigms or ideas shape our relationship with the materials we use every day, and also with the new innovative materials that we are developing in laboratories all around the world.
Before we dive into the very casual questions such as what is life, I want to ask you maybe something that's a bit more personal to break the ice. I noticed you referenced the Chilean biologist and philosopher Varela a lot in your book. And I remember reading in one of his essays a little personal complaint that he had when he moved, I think, to the US to get his PhD, and then how amongst his peers, his philosophical thought was considered like a deviation or a distraction even. And how he would commonly hear a kind of patronizing, Francisco and his philosophy, you know. So I'm wondering, how is that for you? How is the transition, the shifting of perspective for you personally, and how was it received among your peers?
I mean, I feel like kind of lucky, you know, because I have a feeling that right now it is a good time to be doing this kind of research. There is a lot of attention and interest in this kind of interdisciplinary fields. And this kind of interest, I would say, in my experience, mostly comes from the humanities. I feel like in the humanities in general, from philosophy to cultural studies to arts, there is a lot of curiosity towards science, because science really seems to be offering like a new language to deal with questions, philosophical questions. On the other hand, from the sciences point of view, I feel like often there is not as much openness or interest. In my personal experience, the scientific world is still really not very perceptive or open towards this kind of hybridization of different fields. And it really remains very technical and focused on very specific, specialized questions. This is maybe also because of how the academic work and the academic world kind of functions. I mean, when everything really revolves around productivity and how many publications you have, like there really is not much time to explore different things and different fields. I've been lucky, and I'm happy, like I would say, about the reception of my work. Mostly though, like the attention has come from the humanities, while from the scientific perspective. So, I mean, yeah, my peers, my colleagues, it was kind of hard to explain what I was doing, or to kind of communicate it and like to get some feedback. And this is kind of a bit sad, maybe.
Okay, you know, I find it kind of difficult to start this conversation, because we'll be talking about another way of conceptualizing cognition, intelligence, life itself, and radically shifting our ideas of things so ingrained in our thought is very hard. Also because our thoughts exist in a language, and this language is strongly connected to the perceptions and hierarchies that we're trying to challenge, and we only have the same language to challenge it with. So I thought maybe we'd start with some of the words I've already thrown around. We've already been talking a bit about science, quite an established term. It has connotations like objectivity, rigorous scientific method, the advancement of knowledge and technologies. But in fact, this is all built upon a premise of nature, of matter as the world out there, as the passive object. Its truths are then, like objective truths are then unveiled by an active subject that is a scientist, so a man. And this patriarchal and human-centered perspective, along with, of course, politically and ideologically motivated funding, has shaped science as we know it. But you, in your book, you challenge us to rethink these boundaries between matter, the scientist, and start breaking down the structure that we know so well. Can you tell us how?
Yeah, so as you said, there is like at the core maybe of this question, like also a linguistic problem maybe, of what kind of terminology do we use when we speak about the objects of science. And even just by saying the objects of science, I am making a statement about the fact that we are talking about objects and not subjects. So for me, like the starting point was like maybe asking this question, are we really so certain like that we are dealing with objects and not, and there is like no level or degree of subjectivity, in those configurations that that we are used to thinking of as passive objects. And this really comes from, I would say it comes from my experience as a chemist, as a researcher in material science, because I had to deal with the fact that a lot of the objects that I was working with were not really as passive as I thought or as they should be. They were really channeling a certain degree of autonomy from me, the scientist. And I realized that the process of working with these materials often was more like a dialogue than just like instrumental use of me towards those objects, or let's say the typical model of the scientific method of the observer and the object that is being observed. And so like this was kind of maybe the baseline, but from there a lot of other questions started to come up for me, because, well, first of all, sticking with like the linguistic problem, we think of science as a discipline or a collection of different disciplines that study nature. But what exactly is nature is not really so easy to define, of course. And this is especially true when you come from a field like chemistry. So in chemistry, often you don't really study things that are pre-existing your scientific investigation of them. Like there is often a process, and we call this process synthesis, chemical synthesis, in which essentially the process of studying a new molecule or a new material actually is connected to the construction of this material. So you cannot really separate the object of your study as something that pre-exists the process of it being studied. And I feel like philosophically, epistemologically, this opens a new way to look at what science does. And I believe that this is not really true only for chemistry, because in all fields of science, one could argue that the object of that science is actually being constituted or produced through the process of scientific inquiry. So for me, of course, then thinking on this question, like encountering authors like Bruno Latour or Isabel Stengers, really helped me to have the philosophical tools also to explore this problem. But it all started for me from my direct experience of what it means to encounter a scientific object in the lab. So this is like certainly like one issue, like what is nature and where exactly is nature? Yeah, but like from there, a lot of other things emerge. There are questions concerning what life is, how it can be defined, what intelligence is and how it can be defined. Often in our everyday language, we take some of these definitions for granted. We speak of organic and inorganic matter, living and non-living matter, but often a lot of bodies really challenge those boundaries.
Yeah, this is really ground-shattering because deconstructing this subject-object relationship that's so crucial for grasping even most Western philosophical concepts, at least. What are the political and social consequences of such a radical deconstruction?
So clearly there are several layers to the political significance of this, I would say. One aspect is definitely the fact that we start looking at non-human bodies or non-human subjects in a different way. And I feel like this is something that is being developed by a lot of thinkers today, and we are starting to really question the agency, the autonomy, the political agency of a lot of non-human subjects, from animals to plants, even to non-living matter. But then I would say more significantly, and this is something I've been thinking about more recently as I've been exploring new branches of my own research, a lot of what science does is not just simply to look at black holes, atoms, and molecules, but a lot of the things that science studies are things that really are deeply connected with who we are and our own identities. I believe that a lot of this has to do with the question of objectivity in a way. So science produces statements about its objects, and often those statements can have a very strong political impact in many ways. And this happens because often those objects of science are actually ourselves, our own bodies. I would say that like trying to deconstruct, or at least trying to look more closely at these processes of production of objectivity really helps also, or is really a significantly political endeavor, because it really allows us to focus on the fact that those statements that we tend to consider true about ourselves and that can have deeply political impacts actually are constructed. And this, I believe, like is really significant, for instance, like in the field of gender studies, where a lot of what it means to have a gendered body comes from science. And then to deconstruct this scientific knowledge and not look at it as an abstract and unchangeable truth about ourselves is really politically significant, I would say.
Absolutely. So yesterday you mentioned in this field your research of the pregnancy test. And I noticed when I was stalking you on Instagram that you're doing a piece on the male contraceptive pill, which doesn't exist, or at least is not used yet. If maybe you want to share some of this new research, since we've kind of naturally arrived to this topic.
Of course. So yeah, I mean, I've been like working recently on technologies relating or associated to gendered bodies, and how like technologies contribute to the construction of the gendered body. And working in this field, I have focused on all of those technologies that deal, of course, with reproduction and gendered identities. So the pregnancy test was one of those technologies that I have been exploring and working on. I mean, there are several reasons why I am so fascinated by the pregnancy test. Maybe one of those is that it is one of the most common applications of nanotechnology in everyday life. The self-home pregnancy test that we all know is actually based on nanotechnology. It is like a really complex technology, even though like we often maybe disregard this complexity because it is such an everyday device. And it has a complex history. Originally, like in the past, pregnancy tests were performed by using animals or other organisms as, let's say, interfaces to decide whether test was positive or negative. And then the test gradually evolved into like its contemporary form. But what I find interesting in all of this is how a fact that we consider to be so natural, like pregnancy, can only be transformed into objective scientific knowledge through the intervention of a really complex technological network. And this, to me, really points to the complexity of those processes of knowledge production. What does it take to make an objective statement about ourselves and our bodies? And if we realize that there is such a vast, complex network behind those statements that we consider to be so natural, then this also means that maybe those truths can be somehow changed, or that there is a space also of political intervention or political reappropriation of those processes of knowledge production. Then, of course, like you mentioned also, like the political, scientific and social history of the contraceptive pill, both the female and male contraceptive pills. And it is kind of strange because that history really shows how a lot of those differences that we considered to be so natural between binary sexes, male and female, actually are often like kind of constructed technologically. Actually, we could have a male contraceptive pill. We know how to make it. The technology has been there since the 70s, basically. The reason why we haven't done this is complex, but it also has to do with what we expect from different genders and their role in society, what we consider acceptable for one sex and not the other. Maybe what I find so fascinating about these technologies is how they really show the interconnection between science and society and culture, and how, in a way, of course, culture influences science and its development, but also like science and those processes of production of truth also have a deep political meaning. And so like there is this circle between science and culture. And I am really fascinated by that.
So it's not about the unveiling of nature, but more of constructing nature. And this brings us to another field about where does nature end and technology begin if we try to look outside of this perspective of we use technology to modify nature. As we look at technology as an extension of our mind via so many systems and materials, and from papers to computers to this microphone to the writing systems, we delegate our cognition to other material structures, and at the same time our mind is intertwined with our body and its perception capabilities. And it is also extended to other materials. So this rigid boundary between our body and nature, or technology and nature, starts to kind of dissolve once we really get into it.
Yeah, I mean, most of my work has dealt with boundaries or surfaces or interfaces. This is a word that I particularly like. In a way, in the sense that like I've been like interested in like trying to understand where exactly does the human and the non-human begin. This is not like a very easy question to answer, even though it seems intuitive at first, but it is really not. As you mentioned, for instance, from the cognitive perspective, we could argue that a lot of our cognitive processes depend on non-human elements. Like this is the notion of extended mind. And I find like this concept of extended cognition to be very powerful, because it suggests that our intelligence is often dependent on or delocalized over a large network of other bodies. And often we do not think of those bodies as capable of cognition. So the starting point also of my research for Parallel Minds was like trying to answer the question of how can a material be intelligent, or like what does it mean for a material to be intelligent. Like at first I was mostly focused on this like cognitive aspect, and I was interested in like how can philosophy of mind as we know it try to deal with the fact of non-human intelligence or non-human cognition, not only in the field of artificial intelligence as we usually consider it, so AI and the software-based artificial intelligence, but also other kinds of artificial intelligences, especially looking at smart materials and new material technologies that are able to sense their environments and adapt, remember, respond to different stimuli. And as a materials scientist, I have encountered a lot of those materials in my experience. In a way, it really boils down to what we consider to be a human in a way. And to me, the human cannot really be completely separated from its or his or their material culture. And this notion of material culture is something I really care about because it relates to how all of those materials that we produce are an integral part of our society and culture. They are not just simply a byproduct of the human, but they actively participate in the construction of what it means to be human. I often speak about spiders and spider webs, and this is maybe a good metaphor to explain what I consider to be our relationship with materials and technologies in general. Spiders have a very peculiar relationship with their spider webs, in that they produce this incredible material. Spider silk is what you would really consider a smart material because it is really able to adapt to different kinds of environmental conditions. It is a material that can self-organize in a highly complex structure. It is one of the toughest, most resistant materials that we know of, both in nature and technology. So it is a really surprising and incredible material. And what is more interesting, though, is like the relationship between the spider and the spider web. And the fact that the spider uses, or I mean, maybe using is not exactly the right verb, right? Because there is like this kind of symbiosis or cooperation between spider and spider web, in that the spider web really becomes like an extension of the perceptive apparatus of the spider. So the spider is able to enhance its ability to sense its environment through the threads of the spider web. And then the spider web is also transformed in response to this behavior. So in a way, the spider weaves the spider web, but also the spider web weaves the spider or the world of the spider in a way. And we don't often think of non-living materials as symbiotic components of our world, but I would say that they are in many ways. It's not only true for spiders, it's true also for us. And the fact that a lot of our material culture today revolves around specific kinds of materials that we often also throw away, or we don't give agency to those materials, right, culturally. And this is something that we are losing. We are losing an opportunity to extend our own identities and to extend our own worlds in a way.
This is so interesting because it's so hard for us to imagine another kind of intelligence, even when we, at least in pop culture, or these ideas that we have of alien intelligence is not alien to our intelligence at all, because it's always some kind of humanoid creature with the central nervous system, with this control room that, builds a representation of the environment and then sends signals as to how to interact with that environment. And so this also connects maybe to the question of how we define life, of the importance of shifting the way we think about complex systems as made up of parts, as if the parts themselves are the base and the structure is on top of that, again in a kind of hierarchy, as opposed to this way of understanding the whole as greater than the sum of its parts, so to say, of the complex emerging and being completely intertwined and inseparable.
Yeah, so this really brings me back to that point about how science and technology is not independent from cultural paradigms. As you said, it's really hard for us to envision technologies or organisms that are not centralized, because we tend to transfer this centralized paradigm to everything. We somehow believe that this is like the best model possible, even though clearly there are a lot of examples, both in technology and nature, of different ways in which matter and material systems can organize themselves. So to challenge this centralized top-down paradigm is, first of all, like a cultural challenge, and then also a technological and scientific one. But yeah, I have encountered throughout my research a lot of systems that really don't fit into this model or this centralized model of cognition, organization, and structure. This, for me, relates deeply with one concept I really care about, and this is the concept of self-assembly or self-organization. So this is the idea that a material system can spontaneously organize itself into complex structure without any kind of top-down intervention. And we see this phenomenon taking place all over nature and technology. There, for instance, crystals are one example of self-organization of atoms or molecules in a complex structure, and this happens spontaneously without any need for us to control the process. But also, like in biology, viruses are self-organized structures. There are self-organized systems on all kinds of different scales, from the molecular to the cosmic scale. We can see self-organization in like flocks of birds, schools of fish. Even our own bodies are processes of self-organization in a way. And in technology, this is especially significant in the field of nanotechnology, which is the field that I've been working on for my PhD. So it was kind of, nanotechnology was the context in which I started to reflect on this notion of self-organization, because when you start working at the nanoscale and you are working with objects that are exponentially smaller than what you're used to, you really have to change the way you think about control in a way. So, of course, when we think about technology, we are like used to thinking of a certain kind of mechanical paradigm of parts assembled from the top down. But in nanotechnology, this is often impossible, because like there is no way we can individually control millions or billions of individual components and just like manually place them in a certain place or the other. So we have to rely on this ability of matter to spontaneously produce complex functional structures. And this is really fascinating, also if you look at life, as you mentioned. And again, in thinking about life, I believe that we bring with ourselves a lot of pre-constituted ideas and cultural paradigms that influence our view of what life is and how it works. So, for instance, I mean, there is this cultural narrative that life is essentially or can be reduced to like the genetic code. And this is something that like has been deconstructed by a lot of thinkers, especially feminist thinkers, such as Evelyn Fox Keller. However, like this is still like it's a cultural paradigm that is like really difficult to break down for some reason, because we believe that life must be the result of a set of instructions, and that like those instructions must be written somewhere, and that there must be, in a way, someone that reads those instructions and then like builds up matter following like this code. But if you look at living systems, and especially if you look at those systems that are placed at the boundary between the living and the non-living, you will notice a lot of the functions of life emerge from self-organization processes, which are essentially delocalized, and there is like no need to have a set of instructions for this to happen. This happens, as you said, in a kind of non-representational way. In a certain sense, we are used to thinking that like for something to work, we need to have a model of it, also an optical model or a linguistic model of it. But often this is not the case. Like those models come afterwards. And first thing that happens is a delocalized process of self-organization. And this, is especially significant when we think about life and how life came to be, and also how can we replicate the functions of life in technology. There is this whole field of synthetic biology that tries to figure out how we can replicate certain functions of living systems. And this is not only a technological challenge, it is also a theoretical challenge, because as you try to reproduce those functions, you also learn how those functions are constituted. And this really shifts our perspective of what life can be.
Even at the very birth of life, we've underestimated the cooperative function, right? You mentioned this really interesting experiment about reproduction, how, what was it exactly? That it just reproduced itself so much that it lost.
Oh, yeah.
Maybe this as a fun fact for
Yeah. So there was this interesting experiment that was carried out in the 1960s, and that really shows this idea that life cannot be completely reduced to genetic code or genetic information. So essentially, this biologist, Saul Spiegelman, and his research group, they decided to extract the genetic code of a virus, a bacteriophage. And essentially, they just had this RNA molecule that is the genetic code of the virus. And RNA molecules can essentially self-replicate. They can have a basic ability to reproduce. If you have an enzyme and the building blocks of this molecule, and then you have a model molecule, then you can replicate this molecule indefinitely. They tried to replicate this reproduction process of just the RNA molecule, and they performed several cycles of replication of the molecule. And what they saw is that after a few cycles, after 10 or 20 cycles, they realized that the molecule had essentially lost most of its complexity. And after those replication cycles, this genetic code had become so primitive that it was not able to produce an actual functional virus. So this experiment kind of goes to show that if we simply take the genetic code and we take away everything that surrounds the genetic code, the molecule in itself, DNA in itself or RNA in itself, are not able to maintain the degree of complexity that we actually see and witness in living things. There must be some other processes that take place that are not strictly related to genetics or cannot be reduced to the genetic code that actually contribute to this complexity.
Amazing. Thank you so much, Laura Tripaldi, for helping us try to take on the path of a more post-human or post-patriarchal understanding of technology, of minds, of cognition, intelligence, and of life itself.
Nice.
Thank you so much.
Thank you, Neja. Thanks a lot.
Thanks so much for listening, everyone. Next week, I'll be joined by artist Nestor Sire and filmmaker anthropologist Stefan Kuhn to discuss the idiosyncrasies of digital culture in the contemporary Cuban context. So hope to see you then. Scale is a podcast series hosted by myself, Neja Berger. It's curated by Janez, Fakin, Janša, and it's produced by Marcela Okretič for the Aksioma Institute for Contemporary Art. The series is part of the 14th edition of the Tactics and Practice Discursive Program, which was made possible by CON's Platform for Contemporary Investigative Art. For more information on the context, participants, and partners involved, see the links in the description. This episode was recorded and edited by yours truly and mixed by Staš Kramar. The music was created by the amazing Kasper Torkar. You're welcome to visit aksioma.org, where you'll find a wealth of free content. And if you like what we do, consider supporting us on Patreon or by making a donation, but no pressure. That's all for this episode. Greetings from Ljubljana and na svidenje.
Tactics and Practice Podcast.